Tactile-Conditioned Diffusion Policy for Force-Aware Robotic Manipulation. In this work, we introduce FARM, Force-Aware Robotic Manipulation. FARM is an imitation learning framework that conditions diffusion policies on tactile observations. Using the Gel Sight Mini, we convert raw tactile inputs into a physically grounded force representation with a pre-trained feats model, enabling policies to learn directly from demonstrations. We collect data using an adapted handheld Yumi gripper equipped with a Gel Sight Mini to capture contact information. To bridge the gap between human demonstration and robotic execution, we developed an actuated version of the Yumi gripper, enabling direct policy deployment on the robot without the need of retargeting. It all starts with recording how humans perform the task. By using the adapted handheld Yumi gripper, we are able to both demonstrate the required motions and directly apply the necessary grip forces for each task. We train a diffusion policy to replicate these human demonstrations by treating the physically grounded tactile force information as both observation and action. This enables the policy to reproduce the gripper motion while explicitly predicting and controlling the target grip force applied to the object. We deploy the FARM diffusion policy on a real robot using a dual-mode gripper controller that switches between grip width position control and closed-loop force control during contact. Having a force-aware action space ensures reliable task execution while applying similar forces seen in human demonstrations. Without explicit force information, the baselines relying on raw tactile images or vision alone frequently fail, highlighting the critical need for force information. Why should we care about FARM? FARM is an imitation learning framework that integrates tactile feedback into observation and action space by leveraging high-dimensional force data from feats. It ensures reliable task execution across diverse tasks. FARM supports open-source hardware and software, making it widely accessible and adaptable.